So, have you ever found yourself tapping away on one of those brain training apps? You know, the ones that promise to boost your memory, sharpen your focus, maybe even bump up your IQ? Millions of us have. But it all comes down to one massive question. Does any of it actually work? Are these games a real workout for your brain, or are they just, well, fun distractions? All right, so here's how we're going to tackle this. First, we'll get into the huge promise that got everyone so hooked on brain training in the first place. Then, we're going to zoom in on what these games are really targeting inside your head. We'll see what happens when you practice, and then, this is the big one, we'll uncover something called the transfer problem. After that, we'll take a peek inside the brain using some pretty cool tech, and finally, we'll lay out the final verdict you've been waiting for. So first up, let's talk about the core idea, the one that launched a multi-billion-dollar industry. It's this irresistible thought that we can train our brains just like we train our biceps at the gym. I mean, the whole idea is so appealing, isn't it? Spend just a few minutes a day playing a fun little game, and boom, you get sharper, you think faster, you become more intelligent in your actual life. It's pitched as the ultimate mental workout. But is this promise built on solid science, or is it maybe just a bit of wishful thinking? To figure that out, we really need to understand what these games are going after. See, they aren't just training your brain in some vague general way. Nope, they are almost always laser-focused on one specific and incredibly important cognitive system. And that target is something psychologists call working memory. Now, the absolute best way to picture this is to think of it as your brain's active desktop or your mental RAM. It's not for long-term storage, like a hard drive. It's the space where you are actively juggling, processing, and messing with information right now, in real time. And why is this one system so critical? Well, because it's basically the engine behind almost everything we think of as intelligence. I mean, look at this list. Research shows it's the bedrock for our ability to reason, to solve new problems, to stay focused, and even to understand complex sentences. It is the essential mental workspace for all higher-level thinking. Okay, so if these games are built to train this all-powerful working memory, what does the evidence say? Well, the first layer of data we're going to look at is actually really encouraging for the brain training folks. This is known as the practice effect, and it is absolutely undeniable. If you spend a week playing a game where you have to, say, remember the sequence of flashing squares, you will get way better at remembering the sequence of flashing squares. And you see this across the board. Study after study shows that it doesn't matter if you're a kid or a young adult or an older adult, your performance on that specific trained task, it almost always shoots way up. So, case closed, right? The training works. Well, this is where the story gets a whole lot more complicated. Because let's be real, getting good at the game itself isn't why anyone plays. We play these games hoping to get better at life. And this brings us to the single biggest hurdle for the entire brain training industry. It's called the transfer problem. Transfer is pretty much the holy grail here. It's the whole idea that the skills you practice in this one little controlled setting, the game, will somehow carry over and make you better at totally different things, like doing your job, your homework, or even driving your car. This is the real test. But here's the thing, not all transfer is the same. Scientists break it down into near transfer, that's getting better at a game that's really similar to the one you practiced, and far transfer, that's seeing improvements in big, broad, real-world abilities. Near transfer? Yeah, that seems possible. But it's that far transfer that the ads are all selling us. So, is there any proof it actually happens? Well, let's dig into the research. Here's a 2016 study that gave cognitive training to smokers who were trying to quit. I mean, quitting smoking requires huge mental control, right? The result? The training had zero effect on whether they could actually stop smoking. A total failure of far transfer. And check this one out. This really hammers the point home. A study from 2015 found that, yeah, people got better at the specific working memory games they trained on. But that improvement didn't even transfer to other kinds of working memory tests. The benefit was basically trapped inside the one exact task they practiced. And get this, in that very same study, they used a test for abstract problem solving, a really good measure of general reasoning. And what happened? Performance on that test actually got worse after the study was over, for everyone. It just goes to show you can't assume that this kind of training automatically makes you smarter. This pattern of really narrow, limited benefits just keeps popping up. For instance, a study on older drivers. After they did all this working memory training, researchers found only tiny,
barely noticeable effects on a couple of very specific driving habits, like speed and stopping at signs. And on all the other ways they measure driving, nothing. No improvement at all. A pattern is definitely starting to emerge here.
Okay, so the real-world evidence for broad benefits is looking pretty weak. But let's shift gears. What's going on inside the skull? Even if our daily skills aren't getting a boost, is the training still fundamentally changing our brains for the better?
So neuroscientists put this to the test. They hooked people up to fancy brain scanners like fMRIs and EEGs, and what they found was, yeah, brain training absolutely does change the brain. You can actually see it. You see different patterns of electrical activity, changes in blood flow, even physical shifts in brain matter. The training is definitely leaving a mark.
But, and this is a huge but, what do those changes actually mean? Well, one fascinating study concluded that these brain changes weren't evidence of a general training effect. Instead, it was a retest effect. What does that mean? It means the brain wasn't getting smarter in a broad way. It was just becoming incredibly efficient at doing one very, very familiar task. It was learning the test, not upgrading its entire operating system. All right, we've looked at the promise, we've looked at the real-world studies, and we've looked at the brain scans. It is time to put it all together and finally answer our big question. So here is the bottom line, the final verdict. Brain training does work, but only in a super limited sense. You will, 100%, get better at the specific games you play. You might see small improvements on tasks that are almost identical, but the evidence that these games will boost your overall intelligence or make you better in the messy, complicated real world, honestly, it's very, very weak. Those changes in your brain, they mostly just show your brain is getting good at the game, not necessarily getting better at life. And all of this leaves us with one last and really important question. If tapping away at an app isn't the magic bullet for a sharper mind, then what should we be focusing on for our long-term brain health? It kind of suggests that maybe, just maybe, we need to look beyond the screen and toward more complex, real-world challenges to keep our minds truly fit.